And I would suggest that really you kind of look at this on various different levels. On one level, we've got our world. On another level, we've got our nations. And on another level, you've got your local setting. And these things are all worth considering for you as the writer. Again, I don't want you to get to having world builder's disease. I don't want you to spend 20 years doing this unless that's really, your dream. Then go for it. But if you want to be a professional writer, you're wanting to do this faster than that. A few months of all this stuff we're talking about at the maximum would be my suggestion. A lot of it you can design as you go along, particularly if you're a discovery writer. And then later on, you can build in the ramifications of it and interconnect it while you're doing your revision. So let's start up here with the world. By the world, I'm usually meaning this is kind of the stuff that goes on the map at the beginning. And let's talk about some quick tricks for you guys that are doing fantasy or science fiction maps to make it feel realistic. This is going to be a geography lesson, not geography, geology. Quick tricks to making. Is anyone here, by the way, a geology major? Awesome. So you can feel free, Colton, to throw anything at me as I get things wrong. But let's talk about, what are we going to start? Let's start with coasts. Okay, coastlines, number one, are very irregular. They grow very naturally. And oftentimes, coastlines, the best way to come up with an interesting coastline is actually to start watching for natural patterns in places. Isaac talks about this, who does my maps. He sees the best maps come from things like rust patterns or stains on walls or things like this because of, I'm not even sure what the technical reasoning for this is, but coastlines are fractals, meaning as you scale down, they scale up to match you. The further you zoom down in, the more sort of complex and craggy they become. It's not a true fractal, but they follow some of the same fractal behaviors. And so you want your coastlines, one of the big problems is making your coastlines look too regular. Making your continents look like a box is usually a bad move. If you're having trouble with this, go look for some patterns in nature. You will find them. They're around. Yeah.
I just paused a bit. My good friend got a coastline for one of his books from the Foam News Bureau model once.
Okay.
And it worked great.
Yeah. Those sorts of things generally are some of the best inspirations. I've heard it told that if you want a coastline that feels very natural, you can pick an area on Google Maps and zoom in far enough that it's local, and then make that your world map because they follow fractal behaviors. Like if you zoomed in on the coastline, we're not talking the coastline of Florida. We're talking like zoom in on the coastline of a certain city along the Florida and pretend that's the coastline of a continent instead. It will actually follow the same laws and things, and it will feel very natural to you. Okay, so coastlines. Let's talk a little bit about rivers. Which way do rivers flow?
Down.
Flow down. What does this mean?
Downhill.
Okay. Away from mountains. Okay. Toward the ocean. Okay. So, now, because the world is a wacky place, again, none of these rules, you're going to be able to find exceptions. But let's say we've got our mountains right here, and we've got a river that goes like this. What is usually going to be wrong with this river?
Divided.
Rivers don't divide that way. Okay? This is an easy mistake I see a lot of writers make. They don't divide like this in almost all situations. Sometimes you will find them for various reasons dividing like that. Usually it's caused by glaciation or something weird like that. But in 99.9% of the cases, rivers go like this. With rivers combine, rivers don't split. Okay? Very easy way to make it feel more realistic. And if it's going to do this, there's got to be some major reason why it does. Okay? Another problem is having a river go like this, which you'll actually see people do in less extreme cases. Having a river flow away, not directly toward the ocean, is very hard to make happen. It can, if for some reason you've got a mountain range here, which is not a very realistic mountain range. But usually your rivers are going to take the path of least resistance toward your coastline, and they're going to go from heights down to lows. All right. Often rivers will do this, where they have like and there's like a lake here, and then something else is coming up from over here and whatnot, and you're going into your lake, and you will have a bunch of rivers feed into a lake. What is wrong with that?
There's only the one lowest point of the lake where the water's going to exit.
Exactly. Man, you know your stuff. Have you been researching this or something? You just, smart.
I like looking at maps.
Yeah. There's going to be one lowest part in a lake, and a river's going to come out of it. And the basic way that erosion works, that's going to become more and more and more likely the way that the water is going to come out. And it's going to, even if there were for some reason two, one is going to be a little bit better. It will erode out here. This one will fade away, and we'll end up with one river, or will wash away, and your lake will end up shaped like that. And even that's not that likely.
Question: in what cases would you have a delta forming at the base down by the water?
There's a lot of reasons for deltas. You're talking about one of these little guys.
Mm-hmm.
A lot of reasons for those. One is tidal influence. If you've got tides, one of the things to keep in mind is salt water will go up your river a certain amount, and your tide will affect how far up the salt it goes. Another reason would be how strong your runoffs are. Another reason would be what type of soil you're dealing with. As far as I know, Colton, you can correct me on this, you're probably never going to have problem just putting a delta in there. All right? Yeah.
How do we account for various and sundry moons effects on tides?
I go to my physicist friends, and that's what I do. Mark, you got something on that?
There's a fantastic book called What If the Earth Had Two Moons?
There you go. I'm only going to be able to give you generalities here, because when I say something like, I want to have two planets start colliding, what does that do to the gravity? I go to my physicist friends, or rather to my editor who has physicist friends, and they tell us what will happen. So I'm going to give you basics here. So let's see here. Mountains. Yes.
I had a question on, I mean, in this context it would apply to the moon thing, but
Yeah.
it could apply to, how much of it can we, I mean, you've mentioned before that some of it we can pretend.
Yes.
I mean, do you have an opinion on what we can get away with? Like, for instance, in the two moon situation.
Yeah.
If we had a fun idea with that and wanted to run with it, even though it wouldn't stand up to a physics.
I say, as long as you know, go ahead and run with it. Make a magical reason for it. We do fantasy and science fiction. Don't do it in a science fiction book, but in a fantasy book, if it's a cool story you want to tell that could not be told according to the laws of nature we have, that's why fantasy exists. None of this is to contradict the stories you want to tell. All of this is to give you a few rules of thumb, so when you're designing your maps, they feel realistic, and the geologists don't immediately look at it and say, "Oh wow, that's stupid." Again, knowing a few things can take you a large distance of the way there to being very realistic. To get that last chunk, you need to actually do a bunch of research. But I can get you halfway there in a half hour today. By not having your river split the wrong way. By having, following the ideas of how things flow down slopes and things like that, you can get rid of a lot of the quick, easy errors. Another one, let's talk about mountains. Where do mountains come from?
Tectonic plates colliding.
Tectonic plates colliding.
Or
Okay, or volcanoes. And volcanoes often are in areas of tectonic instability, which means a lot of times they will be where the tectonic plates are colliding. And so just going through a little bit in your head, hey, here's one plate, and here, and here's another in this wildly unrealistic blob. You've got these two plates coming together. They're going to be bigger than that. Much bigger than that. You can create your mountain line along here, and you can follow it along and say, okay, around the ocean here, they're colliding here. Hey, we're gonna put some islands down there, and make it realistic along where your plates are hitting one another. Shove up the mountains here, and have places, where the plates used to collide, and it's, they've shifted away from that, and you can then put some worn down mountains in there. Remember, tall mountains with jagged tops are new. Worn down mountains with round tops are old. Very easy sort of way to do it. And so, you can put a lot of, I don't know how to draw mountains. There we go. Jagged mountains along here, if you wanted to. That will be, your tectonic plates. And that will also show you generally where your continental divide is kind of going to be. Not necessarily, but it is a good view for it. And that means that's where the rivers on this side flow that way and the rivers on that side flow that way. Pretty easy to determine. And if you just do a little bit of extra work to determine where your plates are, that can help you to build all of this stuff. Anything on this from the map experts? Colton.
One thing that I always note is that a lot of the new continental mountains generally are forming parallel to coastlines, so you won't generally have mountains in the middle of a continent.
Okay.
They'll be along coastlines. The exception stuff like the Himalayas, we've got two continents slamming together right there, so you get super large mountains there.
Okay, there you go. What's that?
Yeah, ask a question.
Okay, so put your mountains there. Have your rivers run out of your mountains toward the coast. Very easy and simple thing to think about, but you'd be surprised at how often people don't do it. Why do you get deserts? Does anyone know?
Rain shadow.
Okay, rain shadow is one of the two big reasons we get deserts. What is a rain shadow?
Rain shadow is where the clouds with rain can't get over the mountains, so everything behind the mountains is a desert like
That's
Nevada.
right. So we've got Utah. Now, how does Utah form? And there's mountains along it. That's horrible. What's that? I grew up in Nebraska, okay? I don't know about these mountains. But there's a reason why, if you guys go down here, let's pretend that this is Denver. There's a reason why Denver is kind of lush, and across the mountains, it is not. And that is because all of the moisture comes this way, hits the mountains, we get a pressure change. Pressure change causes clouds to form. They dump all of their rain. And then on the other side, all of this humidity that was coming along with this through this movement is gone, and you have this big, huge rain shadow right here with a big desert until you get over here to the coast where things are lush again. That's one of the main reasons we have deserts. So if you're going to put a desert in your world, generally, not always, but generally your desert is going to be either there or it's going to be on the world at the 30-degree parallels. This is just something we've noticed, that geographers have noticed. I'm not 100% sure why, but a lot of deserts get in there because of some reason. Maybe one of you guys can explain it. It has to do with the pressure at 30 degrees. It's the subtropics, and it's hot, but the pressure causes it so that clouds can't form, as I understand.
It's also related to air currents coming in from the
Right.
equator. Is they dump all the rain around the equator. That's why you get a lot of rainforest jungles, and then that water.
Then that